Shuman Ghosemajumder leads product management at Shapesecurity, which defends applications from malware and bots. He's the former click fraud czar at Google, and he will be speaking at the upcoming QCon San Francisco. Shuman, welcome to Software Engineering Daily.
Thanks for having me, Jeff.
I'd like to ease into our discussion of security and fraud with a discussion of bots. What is a botnet?
A botnet is a group of machines that are acting in concert with one another for some purpose. So typically, a botnet is used in a malicious context. So these machines are acting together to be able to attack a website or to be able to achieve some fraudulent goal. And in the vast majority of cases, these botnets are actually end users' own machines that have been compromised by malware and are now looped together into this zombie network that provides computing capacity to whatever criminal wants to be able to use them.
Have bots always been a threat, or is this a recent development?
Well, certainly before the internet, it wasn't really feasible to be able to create networks of computers quite the same way. But since the early days of the internet, we've seen different forms of networked computer activity, and botnets have been around for more than a couple of decades now.
And how has the growth of highly available, easily scalable cloud services like AWS or Google or Azure, do these make it easier for people to spin up really large botnets?
They do. So, like I was mentioning before, you often see end users' machines being compromised and then put together in botnets. But one of the things that you also see is machines on AWS and other cloud services being used in similar types of efforts. Now, it's easier to be able to identify IP addresses belonging to AWS and other cloud services, but one of the things that you typically don't expect is that criminals are going to be putting together a lot of capacity there. So there are a lot of companies out there that are still affected the same way when they see interactions from those sources.
Could you describe some typical types of bots? I know there's like ad tech bots and Twitter bots and all kinds of things. What are some common use cases of botnets?
So ad tech bots are most commonly exemplified in the form of click bots. And in click bots, what you would see is that because there was such a great incentive to click on ads, ad bots would be used to try and simulate the activities of regular users and fraudulently generate a click. And now there are impression bots as well that are fraudulently generating impressions just by reloading different pages on which ads appear and reloading the ads themselves. Twitter bots are used for a slightly different purpose. In those cases, what you're seeing is fake Twitter accounts being created and then being resold in the form of either fake tweets or fake likes that are available for a much cheaper amount of money than it would cost for you to be able to get that same type of activity organically. And there are many other types of bots as well. So typically what you see is that whenever there is any great financial incentive that's available on an application or a website, then there's some type of potential for automation to be able to exploit that at a larger scale than a criminal would be able to achieve manually. And that's when they create a bot.
I'd like to talk a little bit more about the advertising botnets. How big are these botnets and how much revenue or bandwidth are they stealing from legitimate practices?
So bandwidth isn't so much the issue, I think, as how much money are they able to make based off of their interactions with advertising services. I think that when you're talking about large advertising services like Google, they have a very strong direct incentive to try and protect their advertising network against click fraud. And of course, this is the area that I worked on for a number of years. And we invested a great deal of time and resources in making sure that click bot activity and, in fact, any type of fraudulent click activity was dealt with and mitigated and prevented as much as possible. But when you look at other advertising networks, one of the things that you see is that it's a lot more difficult to be able to achieve that same type of scale, not only from the point of view of the advertising network in terms of their investment in click fraud detection and mitigation infrastructure, but also from the point of view of criminal that's trying to get a lot of dollars out of that. So you don't see as much activity in a lot of areas in terms of those advertising networks and the attempts. However, because of the fact that they are often less protected from a click fraud standpoint, you do see that fraudsters have concentrated their efforts more and more on those areas over the years.
A bot can record user behavior, legitimate user behavior, and then replay that user behavior or make slight permutations of that user behavior. On the auditor's end or on Google's end, whoever's trying to detect if a user is a bot or a human, how do you differentiate between a sophisticated bot that's replaying human information versus a legitimate human actor?
That's a good question, and it actually highlights one of the key things that is different about click fraud than other forms of security, and that is that you actually don't have to determine what the intent of a given click is. Instead, what you're looking at is whether or not that click is likely to convert and result in value for an advertiser, and as a result of that, it's perfectly acceptable to take a legitimate click and mark it as invalid and not require an advertiser to pay for it. So in fact, there were many false positives throughout the click fraud detection system at Google, and that was by design, because if you take a legitimate click and mark it as invalid and don't charge the advertiser, then that effectively results in a sale on clicks, and that's actually a good thing from the long-term view of the ecosystem, because if you're getting a sale on clicks, if you're paying less for the total number of clicks that you're receiving, then you actually get a better ROI as an advertiser.
So Google tended to err on the side of false positives in terms of flagging things as bots because they were so conscious of their own systemic fallibility. That's
right. So, and it wasn't just for the purpose of dealing with the limitation in determining what the intent of a click or a clicker was. It was also in order to be able to optimize that ROI. So in fact, there were many clicks throughout the system that Google knew were absolutely legitimate, but weren't very high converting, and they would actually discount those clicks as well.
Interesting. What languages do these bots tend to be written in?
That varies. So typically what you see is that criminals have favorite frameworks and favorite languages that they use in order to be able to get something into a payload that's going to go onto a compromised user's machine. You're typically looking for something that's as small as possible. So you do see a lot of C and C++ being used. However, you basically see bots in every single language that's out there. Whenever you're talking about bots that are actually designed to be run by the bad guy themselves on their own machine or on a machine that is in a cloud computing system, that's when you're not as concerned about the size of the payload, and you can have them written in any language.
How has the software architecture and software ecosystem and culture of botnet programmers changed over time? It sounds like this like kind of dark and submerged portion of the web, but it also sounds like something where there is a vibrant ecosystem and some degree of communication and culture.
Oh, absolutely. There are so many different ways that you can obtain bots and interact with the bot authors. And it's really scaled up over the course of the last 5 to 10 years. So it used to be a lot more underground, and you would have to communicate via IRC. However, now what you're seeing is that there are, of course, forums where you don't have to even be a trusted member in order to be able to start interacting with different bot authors, and you can download the source code for different bots, as well as the bots themselves in executable form directly off of many different websites. And this is partially related to the fact that the bot ecosystem is so vast. So you've got bots that are engaging in highly illegal activity, stealing money directly out of people's bank accounts, like man-in-the-browser bots. But you've also got more gray market sorts of bots that are engaged in activity that isn't necessarily considered to be illegal. However, it's problematic for the websites and the users that are affected by them.
You mentioned man-in-the-browser attack. Could you describe that attack more specifically?
Sure. So a man-in-the-browser attack is the name given to an attack that actually takes over the browser interactions of an end user's computer. And what they typically do is they either steal credentials as the user types them into their browser, or they actually modify the transactions that the user submits into their browser, typically on their banking website, in real time. So if a user logs into their bank's website, the man-in-the-browser malware just sits there silently and waits until the user executes a transaction, and then modifies that transaction so that rather than transferring money, for example, from the user's account to another one of the user's attached accounts, it transfers money out of the user's account into a money mule account controlled by the man-in-the-browser bot master, and then uses that money mule account to be able to transfer the money to the bot master directly.
You recently moved from Google to a new company called ShapeSecurity. Could you describe the origin story of ShapeSecurity and what motivated your career shift?
Sure. So Shape was co-founded by one of my colleagues from Google, Sumit Agrawal, and he had worked at the Pentagon after he left Google. And there he met Derek Smith, who is one of the other co-founders and our CEO. And Derek and Justin Call had previously worked together, and Justin had this great idea for a new way to be able to secure web applications against automated interaction. And that was to be able to change the fundamental premise upon which web applications function. So the web has this legacy architecture where it was designed from the very beginning to be open and accessible and to be able to share information. And so because of this, the source code associated with every web UI in the world in HTML, CSS, and JavaScript form is available to any attacker as well as any user, because a user needs to be able to access that source code in order to be able to render it in a browser. But it's available to any attacker that wants to be able to use that to be able to generate an automated interaction or a bot. And because of that, it's trivially easy to be able to create web bots that interact with websites in automated ways. And this is one of the reasons that we've seen so many bots over the course of the last decade. So Justin's idea was to be able to take that fundamental architecture and shift it so that the quote-unquote source code associated with websites was no longer static and unchanging, but instead was constantly rewriting itself. Because an end user didn't actually care about what the underlying HTML, CSS, and JavaScript look like. What they care about is whether or not they're able to interact with the graphical user interface of that site in a way that makes sense to them. So if you can preserve how that GUI looks while constantly rewriting the underlying code, because of course there are an infinite number of ways to be able to write the computer code for an application, then you create something which is invisible to users but is actually very difficult or impossible for many bots to be able to deal with.
Why is your company called ShapeSecurity?
Because it reshapes the website constantly. So one description of our technology is that it creates polymorphic code, and using polymorphism, we're able to create an inherent defense for web applications. So what I mean by that is that you're not actually trying to necessarily detect malicious interactions so much as by introducing this concept of polymorphic code, the web application itself becomes resistant to interactions from bots that are designed for a static version of that website. So polymorphism in Greek actually means many shapes.
So when you have a polymorphic variety of website versions, how do you ensure that they have the same types of performance? And how do you generate these polymorphic website versions?
So in terms of performance, that's one of the key considerations that we had as we were developing the technology. And there are various levels of optimizations involved there, but the net result is that we typically add less than 20 milliseconds of latency to every page request. In terms of being able to generate the polymorphic code, that's something that is done in a number of different ways. So we have some simple examples of being able to take things like the underlying variable names, essentially, in the code and being able to rename those. But there are much more complex examples as well. So being able to actually change the functionality of a piece of web content in such a way that it does the exact same thing as it did before, but it does it with a completely different path in terms of the code.
One product that you offer is called the Shapeshifter Bot Wall. What is a bot wall?
So a bot wall is the name that a number of different folks have used historically for essentially something as simple as a firewall from a deployment standpoint that would allow you to deal with all of the different types of bot activity that are engaged on your website or on any type of application. And so one of our core focuses as we were in stealth mode and trying to develop the product was to be able to generate the first working bot wall, something that would be simple to deploy but then sophisticated in its defense in terms of being able to deal with all of the different types of levels and methods of bot interaction that were out there. So what we provide is called the Bot Wall service, and it's this bot wall functionality provided in a managed service such that our customers don't have to worry about bot activity at all. They get a number of different reports and analytics, and there's a GUI that they can get information about the bot activity through, but they themselves don't have to worry about protecting themselves actively against bots the way that they currently do, which is typically using IP-based analysis and engaging in whack-a-mole and trying to blacklist different IP addresses on a regular basis.
Does this bot wall leverage polymorphic code?
Yeah, that's exactly what it does. So it takes the web content that's associated with a web application and it constantly changes it in order to be able to create the defense.
So from the standpoint of a bot, how is the bot being confounded by this polymorphic code?
So if you have, I'll just give you one simple example. If you've got a bot which is designed to take usernames and passwords that they've stolen from other websites and test them automatically against the target website's login form, then it might be created in such a way that it looks at the underlying web content that generates that login form and sees that the username field is called login and the password field is called password. And then it takes those stolen usernames and passwords and stuffs them into the login field and the password field. And by doing that, it can create what's called a credential stuffing attack, and it can log into the website millions of times in such a way that looks like completely legitimate user activity. So typically, websites are going to have controls for things like brute force attacks. So if you've got the same IP address that's logging in millions of times, or if you've got the same username upon which someone is attempting many different password combinations, then each of those patterns is easily detected and locked out. So in the case of an IP address that's sending too many login requests, a website would typically have a rate limit and say that you're only allowed to have so many different page requests of any type or login requests specifically in a certain period of time, and after that you get locked out and that IP can't make any more requests. Or in the case of usernames, if you've got 3 attempts on a username that are unsuccessful within a 24-hour period, then the website might lock you out and then you have to wait a day before you can log in again. But this type of activity, the credential stuffing attack that I was mentioning, takes on a different form where using a botnet and using lists of leaked credentials, they're actually using a single IP address to be able to log into a single account, and then they use a different IP address to be able to log into a different account, and they only need to try each account once because they actually have valid credentials. So the way that such a bot can actually be interrupted or blocked by polymorphism is if that bot is looking for those fields that are named login and password, then all of a sudden if those fields are no longer named those things, if they're named something else and they're named something different on every single page request, now that type of bot can't even function anymore. And so then the bot has to evolve into something else. And there are a huge number of users of bots like that, many criminals that are either purchasing bots like that or are renting that capacity that don't have the capability to be able to change those bots themselves. Now, for the criminals that do, we have other answers in terms of what happens when the bot evolves, because of course there's a cat and mouse game associated with the different ways that you can create a framework that automatically interacts with a website. But because of the fact that the previous category of bots account for the vast majority of bot traffic, even a straightforward countermeasure like that results in the vast majority of attack traffic being deflected.
Listeners who want to know more about credential stuffing can look at the show notes. I will be attaching a video that Shape Security did on credential stuffing that's really interesting and clarifies things. So I'm curious about how a potential customer would integrate with Shape Security, or the Shapeshifter Bot Wall, or a different service that you offer. How do you integrate your service into existing enterprises?
So there are a couple of different ways that you can implement it. The most straightforward way is our customers are typically some of the largest companies in the world, and they have their own infrastructures. They control their own web servers and their own load balancers, and we attach the physical appliance directly to the load balancer so that load balancer rules determine which URLs are going to be protected, and those get transformed in both directions. It's a simple reverse proxy in that sense.
And why do you integrate at the load balancer level? Can you talk about that in more detail?
Sure, just to be able to provide the customer with direct control over what gets transformed, as well as to be able to inherit their own high availability infrastructure.
Okay. And does somebody need to be monitoring or operating the Shapeshifter Bot Wall? Like, does the company need a DevOps engineer to operate a GUI or anything?
This is one of the reasons that we provide it as a service. There isn't a direct requirement on the part of the company to constantly look at alerts and monitor output coming from the service. That, of course, is all available, and a security operations team or a network operations team or a fraud team that is interested in being able to get more insight into what's going on their web application and be able to zero in on different attacks that are being deflected has the analytics to be able to do that within the product. But we provide it as a service to be able to mitigate whatever automated attacks are being directed against that application.
I'd like to zoom out and talk about security from a broader perspective. We did a week of shows on security, and one of the motifs was the trade-offs between security and privacy. What do you think is the relationship between security and privacy?
Well, I think that whenever you've got things like data breaches that are occurring, that's the most direct intersection between the two. So in terms of what customers are experiencing these days, that is. So that there are other intersections as well, for example, from a national security perspective, where people are concerned about how much data does the government need to be able to collect in order to be able to protect the country and protect its citizens. But I think that from a direct interaction standpoint, when people have to worry about whether or not their identity is being stolen as a result of a corporate data breach, that's when the issue of privacy and security are directly associating with one another in the vast majority of cases these days. So I think that one of the real questions is how much of investment are different companies making in adequate security in order to protect the privacy of their users. And that's not only from the point of view of protecting data that they have accumulated about their users and preventing that from being breached, but also from the point of view of how are they designing their systems from a data collection standpoint, and whether or not that data collection itself is secure, and whether or not they're collecting more data than they need to. So all of these are pretty complex issues that really require folks that have a great deal of experience in both privacy and security to help shape the policies of different companies. And I think that companies are starting to invest more and more in those areas, not only from a human resource standpoint and getting experts within each of those departments, but also from a technology standpoint and developing and buying more infrastructure to be able to protect their users from both a security and a privacy standpoint.
You mentioned data breaches. The most recent large headline data breach is the Ashley Madison case. And for listeners who don't know, the Ashley Madison is this cheating site where married individuals could find each other and hook up, and it was hacked. So all these users that were intending to cheat on their spouses got exposed. It was this giant news story. And so during Security Week, I asked people about this, and the opinions kind of ranged. Many people said it was this story that is not really, important or momentous, other than the fact that it's this salacious site. But other people said that it was important because it was in the headlines and it was salacious, and it was an opportunity for the security community to say, "Hey, look, if you're not careful, this could be you. And if you use a service that is not careful with the security, this could be you." So have you seen any reverberations through the security community as a result of this Ashley Madison stuff?
I wouldn't say there have been too many reverberations throughout the security community specifically. I think, as you pointed out, it's the nature of that particular site that has made a lot of folks pay attention to the story. And I think that the reverberations are more throughout general society than they are throughout the security community. Within the security community, these types of breaches have become commonplace for several years now. And in fact, that particular site is much smaller than some of the breaches that have occurred before that. So I think that the technical mechanisms that were used are pretty much the same as what we see in other types of breaches, but the fact that it's drawing a lot more attention is something that's beneficial from the standpoint of people now asking questions about what could happen, and what do companies that have even more important types of data, for example, banks, what do they need to be doing from the point of view of being able to protect their users? And of course, organizations like financial institutions have recognized these threats for many, many years and have invested proactively to be able to protect themselves. But I think that increasing public scrutiny lends itself to companies being even more cautious and wanting to invest more and make sure that there aren't any gaps that they've overlooked in their security infrastructures.
During Security Week, we also did an interview with Bruce Schneier, and he was worried about Internet of Things attacks. Like, you could have a bunch of refrigerators with computers or processors in them launching a denial of service attack against, for example, a financial institution like Bank of America. And I guess this kind of sounds like a bot attack, maybe the type of bot attack that ShapeSecurity thinks about how plausible is this type of concerted Internet of Things attack?
It's very plausible. So I think that refrigerators are a very good example because you're seeing internet functionality put into refrigerators as well as other household appliances in ways that a lot of folks are questioning now. They're wondering, is it really necessary for this appliance to have internet-connected functionality? And the fact that it may be running a Linux operating system, for example, or is something capable of being able to send web requests, that allows it to function the same way that any compromised machine would function if it were taken over. And in a lot of cases, the manufacturers of household appliances are not security experts. In fact, they're not even necessarily software experts because they're adding this functionality onto what's fundamentally a hardware device that previously didn't have any kind of network connectivity. So if that lends itself to having more security holes in those types of appliances and having thousands of different categories of internet-connected appliances that are now easier for a bad guy to be able to compromise than regular PCs and tablets are, then that's, of course, where their attention is going to shift, and that's where we're going to see the next generation of botnets.
What are the ways to prevent these botnets?
Well, again, I think that it requires the right amount and type of expertise in the development of these types of appliances and these types of features. And the problem there is that I think that a lot of this functionality is being created just for marketing purposes as opposed to any type of real benefit to the purchasers of these appliances. So as a result of that, there isn't as much care that's being taken in the construction of the network functionality. And I think that it's going to take a while and probably some incidents before people are going to start wondering, whether or not we really need to have that type of internet-connected functionality in something like a refrigerator or a toaster. I think that one of the other questions that is raised here is how do people think about the best way to be able to protect themselves overall? Because if your own refrigerator is compromised and is used in a botnet-based attack, that hasn't actually hurt you necessarily. It's hurt whoever was the victim of that attack, whoever the target of the botmaster was. So the incentives aren't necessarily clear in terms of you yourself as a consumer not wanting to have that internet-connected functionality in the refrigerator that you buy. You probably don't want that internet-connected functionality in someone else's refrigerator or in the refrigerator ecosystem, but you don't care as much in terms of your own individual refrigerator. So this is just one of the complex issues that will probably take some time and education for the industry to resolve. But in the meantime, I think that the concern is what can you do as an application owner to be able to protect yourself and to protect your users?
Who is in charge of these types of botnets that you see? For example, the advertising botnets. Is it a particular nationality or company type? Who is it?
In terms of nationalities, it's distributed all over the world. So you see a great deal of activity from the United States. You also see it from just about every other country in the world. Now, there are concentrations in terms of different parts of the world that have more basically computer science talent. That's what it comes down to in terms of wherever you see folks that have the capability to be able to create sophisticated software, you see it being used for good as well as for bad. And in terms of the targets of these attacks, you similarly see them distributed all over the world. I've spoken with companies in every part of the world, and they're the victims of the same types of attacks.
Interesting. I'd love to get more insight about what you saw when you were working on ads at Google. How much advertising fraud is there on the internet?
So there is a fraud scheme associated with just about every single major web service, and the extent to which that is engaged in by criminal organizations and by individual fraudsters is directly proportional to the amount of money that they can get out of the system. So one of the key incentives in advertising fraud was being able to get a check from the advertising network or from the advertisers themselves via the advertising network. And when you have that type of incentive, you see a great deal of sophistication and effort that is put into creating the tools associated with that attack. And so we would see many different types of tools that are created, from simple clickbots to actual botnets to management frameworks that would enable people to recruit others who would sit in cyber cafes and click on ads all day in some kind of organized format. Now, the extent of that is also directly related to the size of the advertising network. So in the case of Google, we would see thousands of attackers from all over the world on a daily basis, and that was one of the reasons that Google would actually mark millions of clicks as invalid on a daily basis.
What about on sites like Facebook and Instagram? Maybe you're not as familiar with how much fraud these types of companies deal with, but is there any added layer of security based on the close identity contract that Facebook has?
There is. It's a complicated relationship with dealing with fake accounts and fake likes when you're talking about social networks, because of the fact that the social networks are trying to enable automated interactions themselves in some ways. So, for example, when you look at Twitter, one of the things that you see is that they are essentially replacing what RSS feeds used to do a number of years ago, and they're allowing news organizations to be able to use bots to be able to tweet out new headlines. But when you're talking about fake accounts, that's when you're really talking about fraud, and users are concerned when they see large numbers of fake accounts and fake likes that are existing on Twitter and Facebook. So that's where they have similar types of controls, but they're set up in a different way because of the fact that the interactions of those bots go beyond a single click, for example. So in the case of a fake Facebook user, one of the things that the bot master needs to do is not only create the account and use it to be able to like different content that they want to be able to promote, or to be able to create different fake interactions of other varieties, but they also need to be able to maintain that profile's interactions in such a way that they elude Facebook's detection systems. So, for example, if Facebook were to suddenly see 1 million fake accounts created overnight that all liked the exact same piece of content, or they all sent out the exact same message, that would be very easy to flag and deal with. So instead, what the fraudsters are trying to do is make each of those accounts look like they're unique. And that requires a lot more sophistication in terms of what we call persona management software.
There's this cat and mouse game that always occurs with any sort of security problem, where the people that are trying to evade the security experts are, they'll find some exploit, and then the security expert eventually also discovers that exploit. But there seems to be this time window where scammers or people who are evading the security experts do get to exploit a security hole. In that type of scenario, like if you have some bot master that is exploiting some hole in the Google advertising system and making tons of money for a long period of time, and then Google discovers it, how does Google audit the backlog of potentially fraudulent behavior? Or are there scenarios where Google just discovers this exploit and then has to say, oh my God, there's no way that we can go back in time and replay all these transactions? Or how does that play out?
So in such a scenario, and that's pretty rare that Google would discover a number of different interactions or transactions that completely made it through and were missed by their detection systems. They can simply go back and refund the money to the advertiser and retroactively mark those clicks as invalid. So you don't have to actually rerun them through the system.
Okay, so I was probably over-dramatizing.
Well, I think that it's a very real concern in terms of other types of industries, though. So, for example, if you've got money stolen from someone's account, and that has ripple effects in terms of affecting that person's credit, if a check bounces, and you've got all kinds of other ways that somebody can be affected by identity theft, of course, it's really difficult to be able to fully restore that user.
Interesting. So I'd love to hear about the ways that advertising fraud changed while you were at Google. You were an early product manager on AdSense. What were the ways that people were exploiting the system then, and how did that change over time or become more sophisticated?
I think that in the early days you would see more individual clickers and pretty unsophisticated types of schemes, and they just got more sophisticated over time. So we would see more botnet-based activity, more automation frameworks that were being used. And this is the type of evolution that you typically see in any industry. So when people realize that you've got a business which is growing and there's the capability for someone who is able to successfully defraud it to be able to extract money from that system, then they put a lot more energy into trying to come up with sophisticated ways to get around the defenses that they think are there. But of course, that was one of the reasons that we continued to invest in our security infrastructure and tried to stay ahead of whatever the bad guys were doing.
You're going to be giving a talk at QCon San Francisco. What's going to be the content of that talk?
So I'm going to be talking about the imitation game, and in that phrase, I don't mean the movie, although, of course, the movie has helped popularize the term with the general public, but I mean the original name that Alan Turing gave to the Turing test. So how the imitation game or the Turing test has now become essentially the primary area of focus for criminals as well as for defenders on web applications and websites. So you can do a lot from a security perspective to be able to secure your infrastructure, and you can close every hole that might exist from the point of view of portions of your infrastructure that are not available to be directly interacted with by your users. But whenever you're talking about a user interface, that essentially represents a different type of area where you always want to maintain as much accessibility and keep that as friction-free as possible for your legitimate users. Otherwise, you actually hurt your business and you make it difficult for your customers to be able to use your application. And that actually represents an opportunity for attackers to be able to hide within that legitimate traffic and interact with your site the exact same way that a legitimate user does. And so if they can pass the Turing test or win the imitation game, then they're going to be able to beat your security systems on the user interface layer, and they're going to be able to perpetrate fraud on your system. So the question is, how do you protect that user interface layer in 2015 without harming your user experience?
And from a more human, individual standpoint, the Ashley Madison case, I find it so dystopian because one of the things that was going on, I don't know how much you've looked into this case, but there were engineers at Ashley Madison that were actually creating bot accounts that would communicate with mail customers. So mail users would log on to the site and like begin looking for somebody to hook up with, and they would end up messaging a bot, and the bot would respond and be like, "Hey, how's it going? Like, let's have a conversation." It's like very dystopian when you begin to have these services that are actually generating bots, and these bots are passing the Turing test in order to create customers. I mean, have you heard of this? And what does it make you think of? Is this as dystopian to you as it is to me?
Well, I think that the types of bots that were described were actually pretty simplistic when it comes to their design and the types of messages that they would send. So any sophisticated analyst would look at those types of content and they would be able to flag it as a bot right away. But we're actually seeing much more sophisticated types of bots that are able to do more complex forms of actions on other websites that actually have a great deal of defense that has been put in place. And one of the things that makes me not think of it as too dystopian right now is the fact that they're all of these tools are still firmly in the category of what we call weak AI tools. So it's not like the software is capable of actually reasoning the way that a human being does. It's not problem solving in any type of meaningful fashion. Instead, they're simply performing repetitive actions the way that their human authors have programmed them to. So I think that it's all a question of staying ahead in that cat and mouse game and being able to flag the tools as they're coming in.
Your career has touched on music and advertising and public health and security, and we didn't get into some of these topics, but you do have a cornucopia of interests. What were the invisible threads that connected these disparate topics within technology, and how did they strengthen your expertise?
Well, I think without a doubt, the invisible thread is the rise and ubiquity of the Internet. So it's hard to imagine a time, I think, for most folks in the technology industry now when there wasn't a commercial Internet and a commercial web that everybody in the world that was using computers was essentially connected to. But it has enabled forms of content sharing and interaction and commerce that I think were very difficult to conceive of and understand exactly what they were going to look like when they were at the incipient stage. And even now, I think we're still struggling to understand what all of this content and all of these business models are going to look like 10 to 20 years from now. So we're still seeing innovation in terms of new business models and new types of functionality and trying to understand what the long-term effects are. So data breaches are one example of this. We've all created hundreds of accounts on so many different systems, given so many different websites, our data and user information, and we're only now starting to understand what the ramifications of that really is. And similarly, when we're looking at the music industry, we're still seeing innovation in terms of the business models. We're seeing Apple coming out with their first streaming service just this year, and I think that it still remains to be seen exactly what the dominant business model for music distribution is going to be in the next 5 to 10 years.
Shuman Ghosemajumder, thank you for coming on to Software Engineering Daily.
Thanks very much, Jeff. I really enjoyed it.
Yeah, so I'll see you at QCon. I look forward to chatting with you.
Likewise. Good chatting with you, Jeff.